Welcome to Cosmic Echoes. Today we are diving deep into a question that I think is both timeless and incredibly relevant. How did seven pioneering astronomers transform our understanding of the universe? We are going to explore not just their groundbreaking discoveries, but also the societal and philosophical shifts that they sparked.
I think it's so fascinating to consider how these astronomers, often working with, limited technology, managed to just reshape our entire worldview.
Yeah.
Their dedication to observation and challenging the status quo is truly inspiring.
Absolutely. So let's start our journey back in the 15th century with Nicolaus Copernicus. Now, most of us know him. He's the guy who put the sun at the center of the solar system.
Yeah.
But what's truly remarkable is how his heliocentric model went beyond astronomy.
You're right. The prevailing geocentric view with the Earth at the center was just so deeply intertwined with religious doctrine and philosophical thought. Copernicus's challenge to this wasn't just a scientific debate, it was a seismic cultural shift.
It's almost hard to grasp how radical that idea was at the time.
Yeah.
Imagine believing your entire life that Earth was the center of everything, and then someone comes along and says, nope, we're actually revolving around the sun.
And Copernicus wasn't working in isolation. He drew upon ancient Greek ideas, refined them, and developed a detailed mathematical model that more accurately explained the observed movements of the planets.
He knew this would be controversial, right?
Yeah,
Especially with the church's influence at the time.
absolutely. He delayed publishing his book on the revolutions of the celestial spheres for years, acutely aware of the potential backlash.
Wow.
It wasn't published until 1543, the year he died.
Oh, wow.
Talk
Okay.
about a lasting impact.
His work truly ignited the scientific revolution. It encouraged people to question long-held beliefs and rely more on observation and evidence. That's a legacy that extends far beyond astronomy.
Precisely. It set the stage for a new era of scientific inquiry, one where evidence and reason were paramount.
Now, fast forward about a century to Galileo Galilei, born in 1564. We often call him the father of modern science, but what really earned him that title?
Well, Galileo championed the scientific method, testing theories through observation and experimentation.
Yeah.
He didn't just rely on ancient texts or philosophical arguments. He wanted to see for himself how the universe worked.
And that's where his famous telescope comes in, right?
Exactly. With his improved telescope, he made groundbreaking observations that shook the foundations of the geocentric model. He observed the phases of Venus, which could only be explained if Venus orbited the sun, and he discovered 4 moons orbiting Jupiter, the first moons ever discovered around another planet.
That must have been mind-blowing at the time to see these celestial bodies moving around another planet, not Earth. It directly challenged the idea that everything revolved around us.
And it's important to remember the context. Galileo's support for the Copernican model put him in direct conflict with the Catholic Church, which held on to the geocentric view. He was eventually put on trial and sentenced to house arrest for the rest of his life.
It's a stark reminder of how scientific progress can be met with resistance, especially when it challenges established beliefs.
Absolutely. But Galileo's courage paved the way for future generations of scientists to challenge dogma and rely on evidence-based inquiry.
So we've got Copernicus shaking things up with his heliocentric model, and Galileo providing observational evidence to support it, despite the risks. Where does our cosmic journey take us next?
Let's move on to Johannes Kepler, born in 1571. He's often remembered for his laws of planetary motion, but his contributions go beyond that.
Didn't he work with that meticulous observer, Tycho Brahe? I remember reading about his incredibly detailed star charts.
You're exactly right. Brahe's precise observations were invaluable, but he lacked the mathematical tools to make sense of them.
Ooh.
Enter Kepler, who inherited this treasure trove of data after Brahe's death.
And with that data, Kepler was able to make some incredible breakthroughs, right? Like the fact that planets don't move in perfect circles.
Exactly. He discovered that planets move in elliptical orbits, which was a radical departure from the ancient Greek idea of perfectly circular orbits.
Wow.
He formulated his 3 laws of planetary motion, accurately describing how planets move within our solar system.
So Kepler's laws provided this incredible framework for understanding planetary motion. But was there anything that explained the force behind it all? What kept the planets in their orbits?
That's where our next astronomical giant comes in, Sir Isaac Newton. Isaac Newton, born in 1643, he really revolutionized our understanding of the universe. His law of universal gravitation, that explained the force that governs the motion of not just planets and moons, but like everything in the universe.
It's amazing to think that the same force that causes an apple to fall from a tree also keeps planets in their orbits. How did Newton even begin to connect those dots?
Well, he had a remarkable ability to synthesize information, He could see patterns that others missed.
Hmm.
And by building upon the work of Kepler, Galileo, and others, he was able to develop this groundbreaking law.
So for those of us who aren't physicists, can you break down this law of universal gravitation in simple terms?
So essentially, it states that every object in the universe attracts every other object with a force that's proportional to their masses
Okay.
and inversely proportional to the square of the distance between them. So the more massive the objects, the stronger the gravitational pull.
Okay.
And the farther apart they are, the weaker the pull.
That makes sense. So a planet with a larger mass would have stronger gravity than a smaller planet. And a planet that's farther away from the sun would experience a weaker gravitational pull than a planet that's closer.
Exactly. And this is why planets farther from the sun take longer to orbit. They're moving slower because they're experiencing weaker gravity.
Newton's work really transformed astronomy into a predictive science, didn't it?
Absolutely. His laws of motion and gravitation allowed us to calculate the movements of celestial objects with incredible accuracy. We could predict the orbits of comets, understand the tides. We could even discover new planets like Neptune based on their gravitational influence on other celestial bodies.
Wow. Newton's impact on science is undeniable. But beyond his laws and theories, wasn't he also a brilliant inventor?
Oh, absolutely. He invented the reflecting telescope, which used mirrors instead of lenses.
Okay.
This significantly improved astronomical observations, allowing for clearer and more magnified images of distant objects.
So not only did Newton unlock the secrets of gravity, but he also provided astronomers with a better tool to explore the universe. Now let's fast forward to the 20th century where we meet Edwin Hubble, born in 1889. He's the one who really expanded our understanding of the universe's vastness, right?
Yeah, that's right. The Hubble Space Telescope. It's named after him for a reason. His discoveries revolutionized cosmology. Using the powerful Hooker telescope at Mount Wilson Observatory, Hubble observed distant galaxies and made a remarkable discovery. They were all moving away from us.
Wait, so other galaxies were moving away from us. How did he even figure that out?
He observed something called redshift.
Okay.
It's similar to the Doppler effect you hear with sound. Like as a sound source moves away from you, the sound waves stretch out, making the pitch lower. Similarly, as a galaxy moves away from us, the light waves stretch out, shifting towards the red end of the spectrum.
So redshift means things are moving away. But how did Hubble know these were other galaxies and not just stars within our own Milky Way? That seems like a pretty big leap.
That was a major debate at the time. Before Hubble, many astronomers thought the Milky Way was the entire universe.
Wow.
But Hubble observed these fuzzy patches of light called nebulae
Right.
and noticed that some of them contained Cepheid variable stars.
Cepheid variables. Those sound familiar, but can you remind me what they are?
So they're stars that pulsate in a predictable pattern. The period of their pulsation is directly related to their intrinsic brightness. This means astronomers can use them as standard candles to calculate distances.
Okay.
Hubble realized that some of these Cepheids were far, far away, much farther than any stars in our Milky Way, indicating they must belong to entirely separate galaxies.
So Hubble proved that our galaxy was just one among countless others. What a humbling realization. But what about the fact that these galaxies were moving away from us? What did that mean for our understanding of the universe?
That's where Hubble's law comes in. He found that the farther away a galaxy is, the faster it's moving away from us. This discovery provided strong evidence for the Big Bang Theory, the idea that the universe originated from a hot, dense state and has been expanding ever since.
So the universe wasn't static and unchanging as many had believed. It was dynamic, expanding outward from a single point. Hubble really shook things up.
Yeah.
Okay, so we've gone from an Earth-centered universe to an ever-expanding one. Where do our cosmic explorers lead us next?
Let's move into more modern territory with Stephen Hawking, born in 1942. Now, he's best known for his work on black holes, but his impact extends far beyond that.
Stephen Hawking is such an iconic figure. Despite living with ALS, he made groundbreaking contributions to physics and cosmology. His book, A Brief History of Time, was a bestseller, bringing complex scientific ideas to a wider audience.
He had a remarkable ability to communicate complex scientific concepts in a way that was both accessible and thought-provoking. And his work on black holes, which were once thought to be these cosmic vacuum cleaners that swallowed everything in their path, was truly revolutionary.
Right. Black holes are regions where gravity is so strong that nothing, not even light, can escape. What could Hawking possibly add to our understanding of these enigmatic objects?
He proposed that black holes weren't completely black after all.
What?
He suggested they actually emit a faint radiation due to quantum effects near their event horizon.
Wait, so even though nothing can escape a black hole, they still radiate energy. How is that possible?
It has to do with the strange world of quantum mechanics. Near the event horizon of a black hole, virtual particles, which constantly pop in and out of existence, can be created.
Okay.
Sometimes one of these particles falls into the black hole while the other escapes as Hawking radiation.
So even black holes, these seemingly invincible cosmic giants, can lose energy and eventually evaporate over time.
Exactly. Hawking radiation was a groundbreaking discovery, linking the worlds of general relativity and quantum mechanics. He also made significant contributions to our understanding of the Big Bang and the early universe, exploring concepts like imaginary time and the possibility of a universe with no boundaries.
Hawking's work expanded our understanding of the universe in profound ways, pushing the boundaries of what we thought was possible. So we've covered Copernicus, Galileo, Kepler, Newton, Hubble, and Hawking. That brings us to our final cosmic pioneer, Carl Sagan.
Carl Sagan, born in 1934, wasn't just a brilliant astronomer, but also a gifted science communicator who inspired generations of scientists and enthusiasts. He had this unique ability to make complex scientific concepts accessible and exciting for everyone. He really had this way of making you feel like you were right there with him, exploring the universe.
Yeah.
He was a master storyteller, weaving together science, history, philosophy, and just human emotion. He wasn't just teaching you about science, he was sharing his passion for it, inspiring a sense of wonder and awe about the universe.
One of the things I remember most vividly from Cosmos was that pale blue dot image of Earth. The one taken by Voyager 1.
Oh, yeah.
It was this tiny speck suspended in a sunbeam, and it really drove home the fragility and preciousness of our planet.
That was Sagan's genius.
Yeah.
He could connect with people on an emotional level, reminding us of our place in this vast universe. He was also a strong advocate for scientific literacy and critical thinking, recognizing that science wasn't just a body of facts, but a way of approaching the world.
He also played a key role in NASA missions like Voyager, right? Wasn't he involved in creating that golden record?
You're right. He was part of the team that created the Voyager Golden Record, which was placed on both Voyager spacecraft. It was essentially a message in a bottle to the cosmos. This collection of sounds and images intended to represent humanity to any potential extraterrestrial civilizations that might encounter the spacecraft.
So like a cosmic time capsule, sharing a snapshot of humanity with the universe.
Yeah.
It's such a beautiful and optimistic gesture.
Absolutely. It included music from different cultures, greetings in various languages, and even sounds of nature. It was a testament to humanity's curiosity, creativity, and desire to connect with the unknown.
It's incredible to think that these Voyager spacecraft are still out there carrying this message from Earth billions of miles away.
It's a powerful reminder of the enduring legacy of these pioneers. Their work has not only expanded our understanding of the universe, but also inspired generations to continue exploring its mysteries.
It's truly remarkable to see how each of their discoveries built upon the work of those who came before them. It shows how scientific progress is a collaborative effort, spanning centuries and continents. It makes you wonder what mysteries of the universe future astronomers will unravel, building upon the legacy of these 7 pioneers.
That's a question that sparks the imagination. Imagine the possibilities. Discovering life on other planets, unlocking the secrets of dark matter and dark energy, or maybe even finding evidence for parallel universes.
Whoa, parallel universes. Now you're really getting my brain spinning. But seriously, it's mind-blowing to think about what future generations might uncover. We've come so far in our understanding of the universe, and yet there's still so much we don't know.
That's the beauty of science. It's a never-ending quest for knowledge. Every answer leads to new questions, pushing us further down the rabbit hole of discovery.
And the coolest thing is that we're all part of that journey in a way. We might not be professional astronomers, but we can still look up at the night sky and feel that sense of wonder and curiosity that drove these 7 pioneers.
Exactly. Whether you're reading a book about black holes, watching a documentary about the Big Bang, or simply gazing at the stars on a clear night, you're connecting with that same spirit of exploration that has driven humanity's quest to understand the universe for centuries.
It's humbling to think that we're just a tiny part of something so vast and ancient, but it's also incredibly exciting to know that there's so much more out there waiting to be discovered.
And who knows? Maybe one of our listeners will be the next great astronomer making groundbreaking discoveries that will reshape our understanding of the cosmos.
Maybe they'll even find those parallel universes. Well, on that note, it's time to wrap up this deep dive into the lives and legacies of these incredible astronomers. It's been a truly inspiring journey.
It certainly has.
If you want to learn even more about these cosmic pioneers, be sure to check out GalileoWhispers.com. Until next time, on Cosmic Echoes.